Okay, here we are, problem 4, and you kind of have all the tricks now. We know that we need to figure out which curve is on top. We need to see if there's an intersection point within our region, and this one very much like the, oops, that's what I was looking for. Oh, I noticed there's an S there, so there might be more than one region. Region's enclosed, and last time we had a region enclosed. So this is going to be similar to number 3 versus me giving you random X values. So we are going to have that first step that we didn't have. Let's take a look. So I've got the curve f of x equals x cubed. So that is my kind of my basic cubic graph, and then maybe just makes it a little longer. Negative x squared plus 2x, and my negative x squared plus 2x is negative parabola. I believe that ends up, but I'm going to double check here. I believe that ends up having a vertex of negative b over 2a. That's negative 2 over 2 times negative 1, which is negative 2 over negative 2, positive 1. So positive 1, let's plug that back in here, and g of 1 is negative 1 plus 2, which is positive 1. So we have a vertex point of 1, 1 for that. That's what I was thinking, which happens to be a point on here as well. And then I'd be going down from there. So not being super specific here. That's a really bad parabola. Oops. I just got to fix up this side a little bit. That is ugly. Yeah, I guess it's going to go more like this. I just wanted them to intersect, which means I'm going to need to make this one go down a little bit more. And you get the idea. I'm seeing 2 regions of intersection. Let's just get a highlight on this. So I've got the first region here, and then I've got the second region here. And it does look like, and again, this is just kind of me sketching out, it does look like my top curve is going to change. So I'm going to do a quick check on that. I need to find the points anyways, and that's going to be setting the equations equal to each other. It does look like this is 0, 0. I have no idea down here, and I was certainly not accurate enough with my graphing. So we're just going to take those 2 equations. X cubed equals negative x squared plus 2x. Get everything on one side. And I'm hoping this factors for us. Negative 2 times 1, positive 2 times negative 1. Okay, that's checking out. So I get x equals 0, x equals negative 2, and x equals 1. So I do have my point 0. This was the one that we found as the intersection point of, the vertex of my parabola. And so this one must be negative 2. And I really don't need the y values if you wanted to for graphing purposes, but that was really just a visual for myself. So I'm going to pick right up with making my 2 integrals and figuring out top curve and bottom curve and setting it up. And from there, honestly, if these are calculator questions, they become pretty quick. So that just depends on how nice it functions. This would be a no calculator, would be the expectation, because we have nice points of intersection. But there would be a good number of these that we'll just throw in our calculator. And always a good way to check your answer. So I got to go from negative 2 to 0. And when I'm going from negative 2 to 0, the top curve is the cubic. And then the bottom curve is my quadratic, my parabola, which is negative x squared plus 2x. And again, I'm subtracting those because my formula is top minus bottom. So that's the first setup. You can go ahead and do that one, or I don't want to forget to do the other half of the problem. So I'm going to go ahead and set it up. And now I'm going from 0 to 1, and they switched. My parabola is now my top curve. So top curve is now the negative x squared plus 2x. And then minus the bottom curve is my cubic. Okay, so we have our work cut out for us, but I didn't give you trig functions, so we can do this, some simple polynomials. Let's go ahead and clean that up. That's going to be plus a positive, and now let's do it. got my antiderivative. I'm going to go ahead and plug in. Putting a plus there, and I'll go back and do that one. I'm just going to work down kind of all this left one here. So I am going to get a 0 when I plug in that first. Each term has an x. So 0 minus my second plugging in is going to be the hard work here, negative 2 to the 4th over 4. Parentheses with a negative, don't forget that. I know you guys aren't going to write it. I'm saying it. You're not going to write it. 16 divided by 4, I've got 4 plus negative 8/3 plus 4. Distributing my negative, 4 and 4 is 8, so I get negative 8 plus 8/3 is what I'm getting for the area of that first region. So if I put those together, that's 24/3 minus 8/3. I just caught a mistake that I made. So maybe you caught it and you were screaming at your computer, aka me. We were supposed to distribute this negative, and I had parentheses there. I completely ignored them, so shame on me. This negative right here, I had minus the quantity negative x squared plus 2x, which absolutely should have changed that to a negative x squared, or sorry, plus an x squared, but minus a 2x. So this should have been a negative. I'm going to carry my negative all the way down through. And therefore, I have a 4 and a negative 4 that are canceling each other out at this point. And I get just a minus a negative 8/3, which is 8/3. So my apologies on that. On to the second one. I'll try to do better this time. Negative x cubed over 3 plus 2x squared over 2 minus x to the 4th over 4. Evaluate that from 0 to 1. This time I'm going to get the 0 at the end. My lower limit of integration, plugging the 1 in. Negative 1 cubed over 3 plus 1 squared is 1 minus 1 to the 4th is 1, so 1/4. So negative 1/3 plus 1 minus 1/4. Those are not nice numbers. But let's go ahead and combine it with, I guess I'm going to go ahead and go to 12ths. Get a common denominator here. So let's multiply this by 4 over 4. That's going to give me 4/12ths. And this is going to give me 3/12ths. So I'm getting 1 minus 3 and 4 is 7/12ths, or 5/12ths for that. So if you're looking separately at them, the second region should have an area of 5/12ths. The first region should have an area of 8/3. And if you didn't switch the top and the bottom curve, you would be subtracting those two. I want to add them, so I'm going to change this one to 12ths. That's going to be times 4 over 4. That's going to give me 32 over 12 plus 5/12ths. Final answer, 37 over 12. If you had subtracted them instead, not switching the top curve, you would have gotten 27/12ths. So that'll be your check of if you did it correctly. Okay, 8 minutes, not bad. Let me know if you have any questions. Otherwise, this is a really great start on how we find area between curves.